Good morning. Okay, today I'm going to show how to use a Casio's fx-570Ex Classwiz operator with the matrix menu to find the smallest eigenvalue, the smallest magnitude eigenvalue using shifted power methods. Okay, let A be a n by n matrix and the eigenvalue of A are denoted as K.G.Tay. Eigenvalue of A is, if you have n by n, then we have n eigenvalue. Okay? Let's label as lambda 1, lambda 2 up to lambda n, such that the magnitude of lambda 1 is greater than magnitude of lambda 2 greater than lambda n. In this case, lambda 1 is the largest magnitude eigenvalue and lambda n is the smallest magnitude eigenvalue. By shifting the matrix A by lambda 1, we get the shifted matrix A. Let's denote as A shifted. Okay, let's denote as A shifted. Okay, such that your A shifted here, the A shifted is actually A minus lambda 1 I. From the original matrix A, we shift it by lambda 1 unit, where the I here is identity matrix, because lambda 1 is scalar. So to do the matrix operation, we need to multiply it by identity matrix. We get the A shifted n with the matrix. The matrix A shifted, we use a power method, we'll get the dominant eigenvalue. That dominant eigenvalue, we denote as a lambda shifted. For matrix A, we do the power method, we get the largest magnitude eigenvalue in the shifted matrix A, and we denote as a lambda shifted. Okay, let's see. Let's look at the lambda shifted here. The eigenvalue will be shifted also from original lambda matrix A. Its eigenvalue is lambda 1, lambda 2 up to lambda n. Okay, after matrix A is shifted by lambda 1 unit, its eigenvalue also will be shifted, such that you have here now become you have here lambda 1 minus lambda 1, so you get 0, lambda 2 minus lambda 1, so the last one will be lambda n minus lambda 1. So you see that in the A shifted, the smallest eigenvalue will become 0, because lambda 1 minus lambda 1. So the maximum eigenvalue will be lambda n minus lambda 1. Okay, that's why lambda shifted is actually the dominant eigenvalue or the maximum magnitude eigenvalue in A shifted. So lambda shifted is actually equal to lambda n minus lambda 1. Hence, the smallest eigenvalue, which is lambda n, will be lambda shifted plus lambda 1. Because when you use power method, when you use power method on matrix A, you will get actually the lambda n, the maximum, the dominant eigenvalue. Now we use power method on the A shifted. A shifted we get is actually the maximum eigenvalue, the maximum or the maximum magnitude eigenvalue, which is lambda n minus lambda 1, where we denote as a lambda shifted. Okay, once you can get the lambda n, then you can get the lambda n is actually lambda n will be lambda shifted plus lambda 1, which is the smallest eigenvalue on the shifted power method. Why we call shifted power method? Because we apply A shifted in the power method, so it's shifted power method. Okay, therefore, for an n by n matrix A, the smallest magnitude eigenvalue lambda n, where the magnitude lambda 1 greater than lambda 2 greater than lambda n, and its corresponding eigenvector Vn is given by the shifted power method. This is actually a power method where only A will be replaced by A shifted, means if k equal to 0, with the initial eigenvector V0, then you have a can find the M1, where the M1 is the maximum absolute value of A shifted, and then your A shifted multiplied with V0 divided by M1, then you get your V1. Then you can get V at step number 1. V at step number 1 is actually your A shifted, A shifted multiplied V0 divided by M1. Divided by M1. Where the M1 is the maximum absolute value of A shifted V0. And the A shifted is actually A minus lambda 1 I. Lambda 1 is the largest eigenvalue of the matrix A. And then the process is repeated until modulus mk plus 1 minus mk less than epsilon. For given epsilon, then the dominant eigenvalue of the matrix A shifted is actually lambda shifted. Lambda shifted is actually the mk plus 1, and hence the smallest eigenvalue of the matrix A, lambda n, because lambda shifted is actually equal to your lambda n minus lambda 1. So the lambda n will be lambda shifted plus lambda 1, and its corresponding eigenvector will be the last Vn, because the lambda n is smaller, so its corresponding eigenvector Vn is the last Vk plus 1. Let's look at one example. Given the matrix A equal to 4, 3, 0, 3, 4, negative 1, 0, negative 1, and 4, find the smallest, magnitude, find the smallest magnitude eigenvalue and its corresponding eigenvector V3, because we have 3 by 3, so you have lambda 1, lambda 2, lambda 3. So the smallest, will be lambda 3, and its corresponding eigenvector will be V3 of the matrix A by using the shifted power method with the V0 V at step 0 equal to 1, 1, 0. Transpose, because this is vector column. To save the space, we make it become row, that's why transpose. Then stop the iteration until mk plus 1 minus mk less than or equal to 0.005. Then, first of all, we find the A shifted. This is the A minus lambda 1. From our previous example, previous video, we get the lambda 1 is actually 7.1622. Then, so it's A minus lambda 1 times the identity matrix. So you have A minus here, you get this one. Or you want to use a matrix mode number 4. Let's say you input the matrix A, 3, 3. Matrix A, you have 4, 3, 0, and then 3, 4, negative 1, and then you got 0, negative 1. Check our matrix A, 4, 3, 0, 3, 4, negative 1, 0, negative 1, and 4. This is a matrix A. The lambda 1 we obtained from the previous video is actually 7.1622. So you want to minus with, this is lambda times I, lambda times I. And we use to find one more matrix. Let's say it's a matrix C, number of row 3, number of column 3. Then you input your identity matrix. Only this is 1. Input matrix C as an identity matrix. And then now I'm going to do A minus lambda 1 times the identity matrix. And then I put the A shifted as a matrix D. Matrix D is a calculator. So I'm going to do options. I create first AC, then options. So after you input matrix in the AC to clear it, okay, now I'm going to call matrix A is number 3 minus 7.1622. Okay, and then shift options. Okay, identity matrix is stored in C. So matrix A minus 7.166 times matrix C. So you get this one is your shifted. Okay, this shifted I'm going to keep in matrix T. So I equal T. So the A shifted is stored in matrix T. Okay, my identity I store in C. Okay, V I'm going to store in T. Okay, A of course I store in A. But okay, V note I store in B. C I keep the identity matrix, and then just now I use matrix A minus 7.1622 multiply matrix C. So I get the matrix answer, and then I keep in matrix T. Keep in the matrix T. Okay, so now I'm going to use the shifted Hall method. So my matrix P is at V, or I in calculator I keep it as a P 110. So I need to go on. I want to define matrix P, 3 rows, 1 column. So 1, 1, 0. 1, 1, 0. Okay. So now to do your shifted Hall method, you take A shifted multiplied BK. You call back the formula. V at step number 1 is 1 over M1 multiplied A shifted by B. No, this is only 1. V at step number 1. So first of all, you have to do A shifted time V note. Okay, where the A shifted I store in matrix T. Okay, V note I store in B. So I will use a matrix multiplication of T times B. Okay, my 6 D is my A shifted, so 6 matrix B multiply V note I store in B, so option number 4. So I get negative 0.1622 and 1. Okay, MK plus 1 is the largest magnitude. So is 1 largest magnitude. Okay, is negative 1. Means the largest magnitude is negative 1, and then take its value including the sign. So it's negative 1. Okay, to get the V1, you take the result of your A shifted V note, which is actually keep in max answer. So straight away you divide by negative 1. So divide negative 1. It becomes positive. Because A shifted V note, all the value is negative, and divide by negative 1, so become positive. So you see V1. V1 now is keep in max answer. Okay. This one, the latest V1 is keep in max answer. So for the next iteration, to get the V2, which is 1 over M2, A shifted multiplied V1. Okay. Where the A shifted still in B, A shifted still. Okay, this one A shifted still matrix T. Now V1 is actually in time max answer. This one is T. So to get your A shifted time V1, now options matrix T multiply, option, metric answer is here. Go down at number 1. You get negative 0.0263, 1.0263, negative 3.3244. You get here. In only first times A shifted V nodes, you use D times V. Then you get the M1, the largest magnitude. Okay, but when you take out the M1, including the sign, to get V1, V number 1, okay, because A shifted VK here is keep in max answer. Max answer is only the latest memory. So you take the max answer, divide negative 1, you get V number 1. And then to calculate A shifted V1, okay, you take D times max answer. Okay, and then you find M2, the largest magnitude, okay, of the A shifted V1, okay, which is negative 3.3244. Okay, so now you take the max answer, divide, take the max answer, divide negative 3.3244. So you get, okay, this is actually V number 2. V number 2, this is 0.0079, 0.3087, 1. Okay, this one. Okay, so to calculate A shifted V2, again you use D times max answer. And you use it. So now option, number 6 times options, your max answer. So you get positive 0.9011, negative 1525, okay, negative 3.4709. We got here. So your M123, M3 is the largest magnitude including the sign. So negative 3.4709. Okay, later on you take, because this one is keep in max answer. This result is keep in max answer. The same with your V1, also keep in max answer. Okay. So to get V number 3, it means V3, you will take your D time, D time max answer already here, okay, and then we already found, okay, this is your M3, so V3 will be your max answer, divide here. This max answer, divide negative 3.4709. Then this will be your V3. Because if this is 3, this is 3, this will be 3, okay, this is will be 2. Okay, where the, okay, here, A shifted, this one, A shifted V2, okay, A shifted V2 is, actually you take, A shifted is stored in D, so time, cos V2, stored in max answer. So you get this result, and then it obtains your M3. So, okay, after you multiply, this one is keep in max answer, so you take max answer, divide this value, now you got here. Okay, so now the latest max answer is here. Max answer is always keep the latest result. So you see now this is the max answer, is latest V3. So you take A shifted, which is D, times max answer. So D times option, answer. So we get 2.5086, go down, negative 3.5577, okay, negative 3.7248. Okay, so now, okay, the latest result is here, the max answer. Okay, your latest max answer is here. Okay, initially max answer here and then move to here, because the latest result is actually keep in your max answer. So you find M1, 2, 3, 4, M4, okay, the largest magnitude, which is negative 3.7248. Okay, to get your V number 4. Okay, so you take this one, which is max answer, divide. Because A shifted V3 is keep in max answer, so you take max answer, divide this one. Max answer divide negative 3.7248. You get your V number 4, negative 0.67359551, give 1. Okay, so now this is max answer. So you take a D by max answer. Option 6 and option 2 down, max answer. So 4.9951, negative 6.0408, negative 4.1173. Okay, take the largest magnitude, which is negative 6.0408. So the next key, B5, take max answer, divide, take this value, negative 6.0408. So this is B number 5, negative 0.8269, 1, 0.6816. To calculate A shifted B number 5, this is A shifted B number 5, A shifted is stored in D. Okay, so D multiply. Okay, this value is stored in max answer. So option, max answer. You get 5.6148, negative 6.3245, negative 3.15, negative 3.1553. Correct. So the largest magnitude here, negative 6.3245. Okay, so we want to repeat until where? Until modulus of mk plus 1 minus mk. So normally the number here at the last digit differ by 4 units, the last digit. So these two still a lot. That's why we still continue, okay, for next iteration, where to get the V6. V6, you take A shifted V5, okay, multiply, divide by here, like this one. So where the A shifted V number 5 is stored in the max answer, so you divide by negative 6.3245. So this is your V6. Negative 0.8878, 1, 0.4989 here. Okay, and then to calculate A shifted V number 6, V number 6 is stored in max answer, A shifted is stored in D. So option number 6, multiply option the max answer. So you get 5.8073. The second value, negative 6.3244. Okay, negative 2.5776. The largest gate magnitude, which is negative 6.3244. Okay, now you see here, the last digit differ by 1. So mean your modulus of M7, this is because mk plus 1, so this is 1, 2, 3, 4, 5, 6, 7. Modulus of M7 minus M6 is equal to 0.0001, which is less than the epsilon 0.0005. Then the largest magnitude eigenvalue for metric A shifted is actually lambda shifted. Okay, lambda shifted is actually, you get here M7, which is equal to negative 6.3244. Okay, 3244. Okay, when you get M7, you have to find, you got M7, 3, you got to find B3. So M7, you got to find B7. Okay, so B7 takes your max answer, but this value, divide here. So divide negative 6.3244. So you get negative 0.9182, 81, 0.4076. This will be your B3. Okay. Okay. So we get the lambda shifted is here. Then remember lambda shifted is actually your lambda n minus lambda 1. Lambda n minus lambda 1. So you want to find, so in this case is 3, because you got the smallest is lambda 3. So lambda 3 will be equal to your lambda shifted plus with your lambda 1. So lambda shifted here, okay, plus with lambda 1, which is negative 6.3244. Then we get 0.8378, which is the smallest magnitude eigenvalue, and its corresponding eigenvector B3 is at the step E7, which is negative 0.91821 and 0.4076 transpose, because this is a vector. Okay, so I will put on the time scale for lambda shifted power method, because using power method or metric A, this is A. Okay, when we do the power method with the initial eigenvector, okay, we'll get the dominant eigenvalue, which is this one. Okay, using the dominant eigenvalue of matrix A, what we obtain is actually lambda 1. Using power method, is always get the dominant, the largest magnitude, you get the lambda 1. So we mistake that. And then if we use power method on A shifted, this is what we call shifted power method. Okay, we'll still get the maximum. However, when A is shifted, the eigenvalue of A from lambda 1, lambda 2, lambda n, when A is shifted by lambda 1 unit, its eigenvalue also shifted by lambda 1 unit. So in this case, lambda 1 minus lambda 1, which will get 0. Hence, lambda n minus lambda 1 will be the maximum. So the lambda shifted you obtain is actually lambda n minus lambda 1. So for this case, we got 3 eigenvalue only. So the lambda shifted that we obtain is actually lambda 3 minus lambda 1. Okay, what we want to obtain is the smallest magnitude eigenvalue, which is lambda 3. So it will be a lambda shifted plus the lambda 1. And its corresponding eigenvector will be always the last eigenvector. So if here you stop at M7, so you must find E7. Okay, only the tricks here. A, I store in A, and then identity, I store in C, or you may do manually. If you do manually, then if you want to store this in C, also can. Okay, but I just purposely show you the operation in metric view. Okay, A, I store in A, okay, and then C, I keep actually my identity matrix, and then I go to the option. I choose A, which is stored in number 3. Option A is here. So I minus 7.1622 using the multiplication button and with matrix C. A, keep the A, C, keep my identity matrix, and then I get the A shifted, I store in B. Okay, for this model, you can have 4 matrices. With the previous model, you can have only 3 matrices. And then plus 1 more metric answer. Metric answer will keep the latest memory of the latest calculation. And then just now when I do it here, how I keep it to D. You just press STO, D is on top of the SIM button, you just STO SIM. Then the max answer will change it to D. Later on, okay, we build the shifted power method table. So this is a metric P, 110 metric P. So the first case, A shifted B node, A shifted B node, first time you use metric P times B. So it's keep in max answer. You get the dominant eigenvalue in the maximum magnitude. The maximum magnitude, which is here, -1, including the sign. And then to get V1, okay, this one, A shifted V node is keep in max answer. So you take max answer right here. Awesome. This one, now this result here A shifted V0 is keep in next answer. So you take next answer divided by M1. So you get V1. Okay, V1 is keep in next answer. So to do the next iteration, A shifted V1, A shifted V1, A shifted is stored in V, V1 is next answer. So for the following A shifted V, okay, VK, you use D by next answer, except the first like D by D. The rest here is D by next answer. And then you pick up MK plus 1 manually to get the next K, VK, because K also keep in the max answer, so you take the max answer, divide this value. Okay, to get the next A shifted, we not take the D by max answer. You get it. That one, max answer divide here. So the process is repeated until okay, modulus MK plus 1 minus MK less than epsilon. Okay, and the last eigenvalue will be the lambda shifted. The last eigenvalue here, this one is the lambda shifted. Okay, and we want to get the lambda 3 will be a lambda shifted plus lambda 1, and its corresponding eigenvector V3 is the last eigenvector. Okay, it is it. Thank you for your